Questions regarding airflow within large or hot fires. Where is the fire going? What changes the direction and how to stop it are covered in this matter. We begin with the first relationship. An extreme fire cannot be stopped other than by a large area which has the fuel removed. It forms an environment of its own, a distinct and very strong change in direction and heavy rains can also stop a fire, but they're rare. Or a combination of these two factors. Suitable pressure bombs dropped correctly from aircraft in a line in front of the fire can drop the flame down from 100 feet or more to 20 feet or less. An initial close drop will slow the fire, giving you more time in extreme fires to set up a defense. While a 100-foot wall of flames will throw embers for a mile or more, a 20-foot flame or less will throw embers a few hundred feet at the most. Nearly all will then quickly be under 20 feet above the ground, making it possible to install an ember curtain, shown later, with a short control burn behind it to remove the fuel. Extreme fires require extreme measures, such as a pressure bomb if it's really bad. The direction of every fire is determined by fuel, its moisture content and density, terrain contours or obstructions in the wind. With dry, dense fuel, the fire intensifies and rises due to thermal expansion. It needs the room. This draws in air at a 5 parts air to 1 part fuel ratio or thereabouts for the burn. The need for air or oxygen must then meet the challenge to keep the fire going, or it dies out or it dies down. When moving 5 times more air than without fire in a direction to feed the fire, the wind reacts accordingly. Where there is an obstruction, air flows around and becomes turbulent, increasing the mixing in frequencies within the flame, adding more heat behind the obstruction, all other things being equal. A fire that forces itself downward into a valley must suck air under the flame. That requires more energy, which reduces the flame, but this can also increase the velocity of concentrated wind in that valley, dependent upon the ease of travel by wind. A fire that follows a hill upward lets wind push itself up the hill, which then uses less energy for the fire itself and therefore increases the flame expansion. A fire that flows around a hill or from one side or other obstruction must also pull the air around that hill, and that costs energy, so it decreases in intensity. A hotter fire pulls in more air, therefore wind resistance to changing direction of the wind can be overcome. The more dense the fuel, the hotter the fire if it gets enough oxygen. Therefore it pulls in more air, therefore the wind direction will change. Fighting massive fire requires controlling the height of the flame. With less extreme examples of fire, it takes far less material to stop the ember flow with a short flame. Embers get the fire burning in advance of the main flame. If you stop the advanced burn, you also stop a main component in wind sourcing for the fire. If you stop the advanced burning, you substantially reduce the speed with which a fire can consume the fuel. The design of an ember curtain to stop the advancing embers is based upon the height of the fire. The hotter the fire, the more oxygen it needs, therefore the wind draw is greater and can turn the direction of a wind source into the flames. Fire can also turns to go up a hill, thereby bringing wind direction with it. Critical to a fire emergency today are the proper tools. Some examples are provided prior to the main film. Critical to the reality of our lives as 8 billion people living on this planet is there are no resources to waste or let burn. There is no time for growing more trees or for building over. So we must protect what we do have. The average American home uses roughly 2,000 growth years of trees to create it. That's how many trees, how long they have to grow all together to create wood so that you can build your actual house. The consequence of this is you are tearing down what the children and the planet need by using more than the planet can produce to replenish itself. To protect what force and more do for us, the public must participate in stopping these fires, being herded away so those who call themselves heroes can pretend or fight too hard is past. You must participate in the fire to stop it. Learn how, use better tools, be prepared. Remembering, like every other trade or profession, those in power over anything always try to increase that power, and they do so by locking the others out. This is about your home. Make sure you are not being locked out, because fire is easy to set and hard to stop. Today everybody is needed because hate is multiplied. The primary cause of that is aggression against the poor, and that comes in many forms, including robotic elements that take their jobs, because those who believe they can control it do want to control everything. So fight for yourself and fight for your world.
And of course you have to have something so you can pull it down, but take a look up to the top here. This is basically 20 feet tall. And you can put a screen wire all the way up there as far as the wind goes. Screen is not very, doesn't collect a lot of wind. And you can cable it as you need to cable it.
Tree responsible for causing fires to spread rapidly can be stopped by a barrier treated with fire retardant. Consequently, a very hot fire is desirable as it is consistent with forest fires and etc. The National Ignition Facility in San Francisco is trying its best to ignite the same fire here on Earth as is on the Sun. Quote, the goal of many NIF experiments is to create a self-sustaining burn of fusion fuel. In this scenario, the attempt is being made to introduce leaves, the most volatile forest fire fuel, which are responsible for spreading fires, to the screen barrier. As you will see, a 14-mile-an-hour wind is occurring and a 7.5 horsepower fan is being used to significantly increase wind force generated. There is dried material behind the screen to prove fire spread. There is also green grass behind the screen without much thatch. It has rained 3 days before. The pipe anchored on the ground holding the bottom of the screen does a good job of separating the ground fire and the green grass on both sides of the pipe. One small area extends as from hot ash drop and then extinguishes itself. Non-combustible materials are necessary to separate the fire from the combustibles. Green grass is not recommended. As the fire progresses, its test purpose is to create flying debris, so the screens will catch that debris and prove spreading fire can be stopped. As you watch, bear that in mind and watch the screen from time to time as these fire spreading fuels are stopped. A secondary screen is also set into place to determine if this is necessary. In aid of the wind and fan to create hot flying debris visibly in the air, the burning fuel is lifted physically into the air so the wind can catch it and throw it onto the screen, where it stays when heavy with fuel to burn, but falls when the fuel source is basically used up or the wind allows it to drop. It is again the purpose of this test to separate the fire from what would otherwise burn due to wind spread by erecting a screen barrier. The barriers are 9 feet tall. Small amounts of hot ash do fall through the screen immediately below. The green grass proves healthy enough to stop the ground fire. The taller the fire structures, such as 60 feet tall or more, tall trees require a larger non-combustible area, expecting roughly 30 feet when using tall screening frames, so that anything over the top will be sucked down by the screen. As debris when closed will cause a wind drop immediately behind it. Summary of the test is that chicken wire is sufficient, smaller screen is better. A burned or non-combustible area or the like of not less than the width of the transport machine should be required to separate the fuel sources. More is better. The test succeeds in doing what it intended to do. A secondary screen is not necessary here. The machinery in use to transport and hold the screen is able to roll over the stumps and the debris and extend by doubling its size with secondary supports. It is simple enough to use. One person can do it. In rough terrain, some type of motorcycle with large tires or other would tow it, or independent electric motor units can self-propel one or more transport units with the aid of a generator. This becomes cheap and simple. The intended manufacturing version of these frames is allowed to set up as a flagpole with supports. It's a tall screen frame within 5 minutes. All patentable aspects of these machines are claimed for the public, regardless of the nation. Protect them. That includes a transport system that collapses together, extends to double its size, has automatic cabling to measure the desired gap with spring-loaded clips or other, supports and carries screening in either rolls or flats, uses horizontal stiffeners for screening with chains or bolts, etc. to attach them to each other. It can be lowered for clearance. The machine transport climbs over rock stumps with a carrier bar axle combined with a lowering support. One version of the machine can be raised easily to create a tall structure. Miscellaneous obvious things such as a winch pulling the units together or raising the screen is expected. Which then becomes the base for a screen extending in height to 20 feet or more. 60 feet is possible with the bigger frame. This requires simple screen barriers rolled onto a reel for fast and easy placement, or for storage. Stored or transported under the carrier, rewound with a hand tool. The screens used here are chicken wire for least resistance to the wind, and because they roll well on a pipe. The edges must be refined for proper usage. One screen on each side of the tall fence pole for stability and control, both anchored in at the bottom, with stiffeners placed every 3 to 4 feet in all versions of the screen. Placed horizontally to retain shape and control. These stiffeners are locked together with chain or any variety of means to control the gap. When it is all tied together, it does become a force against the wind, assuming no great amount of debris is held against it. In that scenario, what is on fire will cause the rest of the debris to fall within a short interval of time, opening the screen again and again.
Alright, this is a representation of what novice people out in the forest trying to stop a forest fire can use for cutting down trees. Just actually. But you do need to protect the radiator, because as you go, if we grab the rope, we can pull the chainsaw into the tree, thereby unlike my dad and almost all Americans, pretty soon you are not going to be able to go to the store and just get more.